glycogen metabolism. So when we are speaking about glycogen metabolism, we are going to speak about glycogen breakdown and also glycogen synthesis. Whatever subject are you going to have from glycogen metabolism, you are going to start by writing, first of all, some words about glycogen. So we have to remember from the first semester that glycogen is a storage form for glucose in our body, and it is found in the muscles and in the liver, and it contains alpha glucose molecules, 1,4 and 1,6 glycosidic bonded. So that means it has a branch structure. Okay. So glycogenolysis. In order to break down glycogen, we need two enzymes. The first one is glycogen phosphorylase, and the second one is the debranching enzyme. Glycogen phosphorylase. Can cut only 1,4 glycosidic bonds. And puts a phosphate group in the first position of glucose. So the result of its action is glucose 1-phosphate. It stops at a distance of 4 glucose molecules from a 1,6 glycosidic bond. I am writing and I am explaining you later. So after I am going to finish writing. Okay, the debranching enzyme. Moves a unit. I-am lăsat să se three glucose molecules on another chain, making a 1,6, a 1,4 glycosidic bond, and after that is cutting the 1,6 glycosidic bond. The result of its action is glucose. So basically, what is happening? This is glycogen. So these are glucose molecules, one for glycosidic bonded. And I have a 1,6 glycosidic bond here. First of all, glycogen phosphorylase is cutting the 1,4 glycosidic bonds. And when I am getting at a distance of 4 glucose molecules from a 1,6 glycosidic bond, it cannot cut anymore. After is cutting the 1,4 glycosidic bond, is putting a phosphate group in the first position of glucose. So I'm going to obtain glucose 1-phosphate. Glycogen phosphorylase is coming after it and is moving a unit of 3 glucose molecules on another chain, making a new 1,4 glycosidic bond. So I am taking these 3 glucose molecules from here and I am moving them here. And after that, the debranching enzyme is cutting the 1,6 glycosidic bond, getting us glucose. So, from glycogenolysis, I'm going to obtain what? Glucose 1-phosphate in large amounts. And very little amounts of glucose. Okay, glycogenolysis is taking place in the liver and in the muscle. And the result is mainly glucose 1-phosphate. So glucose 1-phosphate can be very quickly isomerized to glucose 6-phosphate. So I have glucose 6-phosphate coming from glycogen in the liver and in the muscles. In the liver, I have glucose 6-phosphatase. So I'm going to obtain glucose, which is going to be sent in the systemic circulation and is going to just help all the tissues in our body, especially our brain. In the muscle, I have no glucose 6 phosphatase because glucose 6 phosphatase is found only in the liver and in the kidney. Yes, the places for gluconeogenesis. So glucose 6 phosphate is going to enter eventually in glycolysis, giving energy for muscle needs. So we are saying that the muscle is selfish, making glycogen only for itself, and the liver is altruistic, making glycogen to supply glucose for all our body. So, the regulatory enzyme of glycogenolysis is glycogen phosphorylase. And this is covalently regulated. So, regulated by phosphorylation phosphorylation being active. And now we have to think on glycogen and on glucagon and insulin. So, insulin is going to love or to hate this process. Glucagon is going to love or is going to hate this process. So, insulin wants my blood glucose levels to remain low. So, insulin is not going to like glycogenolysis. Glucagon, by the contrary, likes my blood glucose levels to be high. So, glucagon is going to love this process. Glucagon is having cyclic AMP as a second messenger. So it's going to activate protein kinase A. And this protein kinase A is going to phosphorylate enzymes. So this enzyme should be active in a phosphorylated form. And the phosphorylation is going to be done by another enzyme called glycogen phosphorylase kinase. And this enzyme is also covalently regulated, being active in a phosphorylated form. So I have several steps of regulation because I want to control the process very, very tightly. Yes, it's really important to be sure I am breaking down glycogen exactly when I need to do it. I'm going to think about that. Yes. For sure, probably not. Yes, I'll take notes. So you are supposed to take notes, and I am doing it with a purpose. Yes, so probably you can imagine that it was very easy for me to make PowerPoints and to present all the lessons from PowerPoints. I am not doing in this way this lesson and no lesson in fact, because I really need you to take notes. Yes, I know for sure that from PowerPoint you cannot take notes. So when I am presenting or anybody else is presenting PowerPoints, it's very difficult to take notes because we are speaking very, very quickly. I am writing to be sure that I am not speaking too quickly and you have enough time to take notes. So you are supposed to write exactly with the same speed I am writing, and I am not having a huge speed exactly to allow you to take the notes during the lecture. Yes? And I am going to repeat as much as you need. Yes, so just ask me, put that paper again. Yes, if you are remaining behind. Or I don't understand this part of the lecture. Okay, just explain me and I'm going to explain you once again. Yes, so I have enough patience to do that. Yes, but I want you to take notes. As I am writing, you should also to write. Yes, you just have to do the same things I'm doing because I'm doing all the things with a specific purpose to allow you to just learn much easy. Okay, and then here is the first paper again at some point. I can show it now. Yes, so that's the first paper. Okay, that's the second one. And that is what I'm doing now. Okay, so I have glycogen phosphorylase, which is phosphorylated by glycogen phosphorylase kinase, which is also covalently regulated and is going to be phosphorylated by protein kinase A. Phosphorylates, so protein kinase A phosphorylates glycogen phosphorylase, kinase, and this is going to phosphorylate glycogen phosphorylase, making it active. Okay, so glucagon, adrenaline, and noradrenaline are activating glycogen phosphorylase. Important, glucagon is not having receptors in the muscle. That means muscle glycogenolysis is going to be stimulated by adrenaline and noradrenaline. Adrenaline and noradrenaline are activating muscle glycogenolysis by activating also the receptors coupled with phospholipase C. Phospholipase C, as we should know from the first lesson of hormones, is generating DAG and IP3. And IP3 is increasing calcium intracellular concentration. So, muscle glycogenolysis is going to be stimulated by adrenaline and noradrenaline in two ways: by activating protein kinase A and also by increasing calcium intracellular concentration. So this is practically giving sense to the fact that we are activating glycogenolysis only in the muscle, only when we need energy for muscle contraction. So physical exercise is going to increase a little bit adrenaline and noradrenaline concentration in our blood, and also it's going to increase intracellular calcium levels from several reasons. So also because calcium is having roles in muscle contraction, and also because calcium is going to activate glycogenolysis, breaking down glycogen to give glucose and to let muscle to obtain energy from glucose in glycolysis after that. Okay, what should you know also from the hormone is that glycogenolysis is also activated by cortisol. Insulin inhibits glycogenolysis. Okay, glycogenogenesis. Again, whatever subject is coming from glycogenogenesis, you should start by speaking about glycogen. Yes, the energy storage form for the glucose storage form found in muscle and in the liver, containing alpha glucose molecules 1,4 and 1,6 glycosidic bounded, so having a branched structure. In order to be used for glycogenogenesis, glucose has to be activated as UDP glucose. So, we have learned about this activation process when we have discussed glucuronic acid pathway. So, what do I have? I have glucose 6-phosphate. Always I should start from glucose 6-phosphate because this is the form glucose is found inside our cells. So glucose 6-phosphate being transformed into glucose 1-phosphate and further glucose 1-phosphate is reacting with UTP, making UDP glucose and 2-PI. So I need first of all to activate glucose, and I need also two enzymes. So two enzymes. One is glycogen synthase and the second one is this time the branching enzyme. Glycogen synthase is able to make only 1,4 glycosidic bonds. It cannot make 1,6 glycosidic bonds. It puts UDP molecules on a small glycogen fragment, or if this is not present, on a protein called glycogenin. So, conclusion, it cannot initiate glycogen synthesis. And is an analogy here with DNA polymerase. So also DNA polymerase cannot initiate DNA synthesis. So we need always a primer. Yes. So first of all, we are making a first RNA small fragment, and on that small RNA fragment, we are continuing to synthesize DNA. So, like DNA polymerase, glycogen synthase cannot initiate glycogen synthesis. So, I need a rest of glycogen, a small glycogen fragment, or if I don't have it, I need to use a protein, a specific protein called glycogenin. Okay, the branching enzyme. The branching enzyme is moving a unit containing at least 6 glucose molecules on another chain and is making a 1,6 glycosidic bond. So what is happening? So I have glycogen synthase coming and putting glucose molecules making 1,4 glycosidic bonds. It is using UDP to do that. So I am synthesizing glycogen in the muscle and in the liver. So I have a limited space available. So I can put glucose molecule until this point, and I cannot continue from now on. So what is happening? The branching enzyme is coming and is numbering 1, 2, 3, 4, 5, 6, 6, at least 6. It can take 7, 8, 9, and so on. After I'm explaining. So I'm going to just go in the chat when I'm going to finish everything, or when I'm going to give you a break, and I'm going to answer all the things. Yes. So when I'm going to make breaks, I'm going to answer the things in the chat. Yes. So I'm putting glucose molecules until I am having the space available. When I cannot put them anymore, I am just taking a unit containing at least 6 glucose molecules, and I am making a 1,6 glycosidic bond. So I am moving that here, and I'm continuing with glycogen synthase after that. So putting glucose molecules till I can, yes? When I cannot anymore because I have no more space here, I'm cutting here, moving the 6 unit rest on another chain, making a new one for glycosidic bond. So that's the story. So of course, the regulatory enzyme of glycogen synthesis is glycogen synthase. And of course, this is also going to be regulated by phosphorylation, dephosphorylation. So regulated by phosphorylation, dephosphorylation being active. And now the process is exactly opposite. Yes, being active in a dephosphorylated form. Because insulin is going to love this process. So insulin wants my blood glucose level to become lower. So putting glucose inside glycogen molecule is practically taking glucose out from the blood, putting glucose there. Yes, so insulin activates glycogenogenesis and glucagon inhibits it. Okay, so homework from glycogen. How much ATP do we obtain in muscle from a small glycogen fragment if 1. The resulted glucose is transformed in lactic acid. 2. The resulted glucose is transformed in carbon dioxide and water. And another homework you should do from sugar metabolism. So, homework 2 is galactose and fructose metabolism from the lecture group book. And I'm going to put on your classroom the PDF with galactose and fructose metabolism from the lecture book. Anyway, I'm going to put on the classroom the PDF from all the book. Yes, to be sure that you have from where to study the information I'm teaching you in the lecture. And that's your homework. And now we are going to have a 10 minutes break. But first of all, I'm going to show you again the papers. And after that, we are going to start lipid metabolism. So, glycogen metabolism, glycogenolysis. We were speaking that we need two enzymes, glycogen phosphorylase and the branching enzyme. Glycogen phosphorylase can cut only one for glycosidic bonds. The debranching enzyme is able to cut the 1,6 glycosidic bond. So, what is happening in the liver and in the muscle? So, in the liver, I have glucose 6 phosphatase. So, I'm going to give glucose to all the tissues in my body. In the muscles, I don't have glucose 6 phosphatase, so I'm going to use glucose only for muscle energy needs. Remember, that is a very important thing. Muscle. So, the regulatory enzyme for glycogenolysis is glycogen phosphorylase, and this is tightly regulated by several steps of phosphorylation. Yes, so I have a glycogen phosphorylase kinase, also regulated and phosphorylated by protein kinase A. Adrenaline and noradrenaline, stimulating glycogenolysis in the muscle, also by using receptors coupled with phospholipase C. Yes, so phospholipase C giving DAG and IP3 increasing intracellular calciums. Glycogenogenesis. Yes, I need mandatory to have UDP glucose, as I also need for glucuronic acid synthesis. So pay attention, you can have in your final exam subjects like UDP glucose. So if your final subject is UDP glucose, you have to write also the way I'm obtaining UDP glucose. Yes, so these two reactions, and what I am doing with UDP glucose. So I can use UDP glucose for glycogen synthesis, or I can use UDP glucose for glucuronic acid biosynthesis. Okay, so also for glycogen synthesis, I need two enzymes, glycogen synthase and the branching enzyme. And glycogen synthase is needing a primer, and the primer can be a small glycogen fragment or a specific protein called glycogenin, because it cannot initiate glycogen synthesis. The branching enzyme is just able to make 1,6 glycosidic bonds, moving units containing glucose molecules. And da, spune că sunt în curs și facem mai imediat. Okay. So homework, of course, you just have to take into consideration that when I am making glycogenolysis, I am obtaining glucose 1-phosphate quickly transformed into glucose 6-phosphate, so I'm not going to consume any more energy to make glucose 6-phosphate from glucose. And the other homework to do by yourself, glucose and fructose metabolism from the lecture book, and I'm going to post the PDF with the book on your classroom. Okay, so 10 minutes break, and we are going to see each other in 10 minutes, so 11:15. Okay, questions? Okay, so I have showed you all the papers. Yes? Okay, break, 10 minutes.